Okay, so we're dealing with just solving radical equations now. And what is a radical equation? It's an equation with a radical and a variable and a radicand. So on the inside of that radical. That core concept says that in order to solve, we're going to look at squaring each side of an equation. If two expressions are equal, then their squares are also equal. Same concept. When I do something on one side, I have to do it together. If I want to get rid of a radical, I'm going to have to get rid of everything around the radical, everything that I'm adding or subtracting around it, and then everything that I'm multiplying or dividing, and then take the square, right? Because those are all those are all inverse operations, right? And then with radicals especially, we want to make sure that we don't have extraneous. So what do you think those look like? Check. Okay. Always check your answers. Always check your answers. All right. Do you have any questions before we get started on how to solve equations with radicals in this? Any of you still writing? Okay, so I need to think of inverse operations just like I would when I'm solving an equation. What should I do first for A? Subtract 5. When I subtract 5, what do I get? I get 8. Yeah, I get 8. So, yep, I get 8. And then how do I get rid of that?
Square both sides.
Yeah. Square both sides. And you get what? 64. And then you want to check. When I plug in 64, I take the square root of 64, I get 8. 8 plus 5 is, in fact, 13. What work? And really, that's all there is to it. Okay? So for B, what am I going to do?
Or
Subtract 3, yeah. Subtract 3. So we're just doing linear, it's like how we solve the linear equations. We just have an extra step here. So, or an extra couple steps. Okay, now what else is around that radical that I have to get rid of first? The negative. Right, so I'm going to divide by -1 or multiply by -1. I don't have to flip any signs because I'm not doing inequalities. So, x, square root of x is equal to positive 3. And then what do I do? Then I square it. When I square both sides, I get x is equal to 9. And then I just plug it in and check. 3 minus the square root of 9 is in fact 0. So that is 3 minus 3. So that works. Okay. So, how do I approach this one? You ready first? Subtract 3. Okay, I subtract 3 and I subtract 3, and what do I get? Get 4 square root of x plus 2 is equal to 16. Now what do I do? Divide by 4. Yep, I'm getting rid of everything around that radical first. I'm dividing by 4. That's the inverse operation for my multiplication. And then I get the square root of x plus 2 equals 4. And then what do I do? Then I square it. This is a little more complicated because I have extra steps, but nothing beyond, some simple operations. So x plus 2 equals 16. And then what do I do? Subtract 2. So x equals 14. And then I just want to double check to make sure that this is a solution that makes sense. F4 is the square root of 14 plus 2 plus 3 equals 19. That's 4 times the square root of 16 plus 3 equals 19. That's 4 times 4 plus 3, and that does, in fact, equal 19. Okay. Questions on solving radical equations? All right. Excellent. Okay. Radicals on both sides. What do you think you do? Square 'em. Square both sides. Square one side, square the other side. And then you have 2x minus 1 equals x plus 4. And then I just solved that linear equation, so how am I going to go about solving that linear equation? Yeah, add 1 to both sides first. And then that leaves me with, here, 2x equals x plus 5, and then I subtract x, and I get x equals 5. And then of course I have to plug it in. Make sure it's not extraneous. Well, I get 10 minus 1, that's the square root of 9. And then I get 5 plus 4, that's the square root of 9, that works. Alright. Questions? Not bad, huh? Okay. I have a cube root. What do you think I do with a cube root? Cube both sides. Cube, cube. So, just cube both sides. Get that large number, 1728. Add 2, divide by 5. And we get this root 6. When you plug it back in, 5 times 346 minus 2, and then you take the cube root, you should get 12. And your calculator, again, if you're having trouble inputting that cube root, there should be either a cube root button, or if you can't find it for some reason or you're having trouble with it, just do your caret button and then do you remember? What power do you raise it to if you want to use the cube root? 1 over 3. It's the inverse of cubing it, if you want to cube root it. So if you want to cube it, you raise it to the power of 3. If you want to cube root it, you raise it to the power of 1/3. Okay. Questions? Comments, concerns? No? Okay. Let's look at some situations where we do get extraneous solutions. Let's see what that looks like. Oops, just not right. Alright, if you're watching the video, pause the video, practice the problem, and now I'm going to review the answers. So, here we go. I did 12, 30, 8, 1/4, 125, and 331. 100? Alright. I guess. Okay, let's do number 9. Okay, number 9. What did you do first? Add 4. Cube root y equals 5. And then cube it. Then cube it. Okay? Y equals 125. Good job. Okay. Okay, this one looks a little strange, but we still want to get rid of the radical, so what should we do on the top one? Square it. Okay. I'm going to square this, I'm going to square this, and then I get x squared equals x plus 6. Oh, that looks like a quadratic equation, which I probably have to solve by, what do you think? Yeah, I'm going to have to get things on one side, set it equals 0, and solve by factoring. Or quadratic formula, but factoring is easiest here. So, get everything to one side. Got a quadratic equation. This is easily factorable, I think. Let's see. What multiplies to be negative 6 and adds to be negative 1? Yeah, negative 3 and 2. Perfect. Negative 3, positive 2. Okay. X minus 3, x plus 2 equals 0. So what are my values of x? Yeah. Guess what? One of those is going to be extraneous. Let's find out which one. If I plug in 3 and I check it, I get 3 equals square root of 3 plus 6. 3 equals square root of 9. That works. If I plug in negative 2, is this possible? No. When I take a square root, I'm always going to get a positive, right? If it's negative, it's going to be imaginary. So that's not going to work. That's an extraneous solution. Okay. Does that make sense? Yes.
Why can't you add those two together and get those?
You can, but what happens is you end up with this, which is not true. Okay. That's a lot of red. Let me okay, for the second one, what should I do first? Yeah, let's try 13. When I subtract 13, I get this, right? And then what do I do? Square. Now, I could look at this. I mean, does this make sense? Does this make sense? No. There's no way I can get a negative, right? You're going to solve it and still check and see that it's not extraneous, but you could technically solve here. Because you have this radical, the square root of 5n, set equal to a negative. That's not going to be possible for us. But if we forget that, yeah, thanks. Francis? Oh. Okay, so we're going to square 5n and we get 100. Okay? Then we divide by 5 and 20. Now, that's not going to work. Okay? I'm going to check that. 13 plus is that going to equal 3? No. Okay. So we knew in advance that we weren't going to ever get a real solution, and if you wanted to, you could stop here and see no solution. Or you can continue further and check and see that this makes no sense. It's not going to, you're going to have a number that's obviously bigger than 3. Okay, that's it. We're done with chapter 10. We're going to take our quiz on Tuesday. Do you have any questions? Okay. So, here's the assignment. Now, keep in mind, there's a lot of problems.